Hello, my name is Julian Batshaw. Today we are going to be balancing redox reactions in acidic conditions. So the question states to write the unbalanced chemical reaction that occurs when a solution of iron 2 is mixed with a solution of permanganate ion to create manganese 2 ions and iron 3 ions. So to do this, we need to have an iron 2 ion reacting with a permanganate ion, and that's going to then yield products of an iron 3 ion and a manganese 2 plus ion. All right, so for part B, the reaction is done in acidic conditions. Write the balanced half reaction and the balanced chemical reaction. Indicate the oxidation number for every atom in the balanced chemical reaction. Indicate what is being oxidized and what is being reduced, as well as the oxidizing agent and the reducing agent. How many moles of electrons are being transferred, and if this were an electrochemical cell, which reaction would be at the anode and which would be at the cathode. So let's start off by writing the balanced half reactions. So we'll start off with iron. The balanced half reaction, or the unbalanced half reaction as of right now, is going to be an iron 2 plus becoming an iron 3 plus. Next, we have the unbalanced half reaction for the manganese, and that's going to be a permanganate becoming a manganese plus 2 ion. All right, so now that we've done this, we need to go ahead and determine the oxidation states in order to find out which is being reduced and which is being oxidized. So iron 2 plus is going to just have an oxidation state of positive 2, matching the charge. Iron 3 plus is going to be positive 3. Then permanganate's a little bit different. So oxygen, in most cases, when it's within a compound, is going to have an oxidation state of negative 2. In this situation, there are 4 oxygens, so that would yield a charge or an overall oxidation state of negative 8. So how do we get this negative 8 to become the overall charge of negative 1 for the permanganate? Well, we need to cancel out all of that negative 8 to yield a negative 1 charge. So that means that the oxidation state for the manganese would be positive 7, and here for the manganese 2 plus ion, that would just match the charge again, being a positive 2. So from this, we can determine that the iron was oxidized because it is losing an electron, and the manganese is reduced because it is gaining electrons, right? And that's why the 7 is going down to a 2. All right, so now that we've done this, we need to figure out how to first chemically balance these reactions. So iron's already balanced, it's a 1-to-1 molar ratio. However, the permanganate is not balanced with the manganese because of the oxygen. So we need to add oxygen in the form of water on the product side. So now we have oxygens on this side. However, it's not balanced. So we're going to need to make this 4 moles of water. So we have oxygens all balanced up. However, now this yields 8 moles of hydrogen. So we need to add 8 moles of hydrogen on the reactant side. So now we're all chemically balanced in the permanganate going to the manganese half reaction. However, we need to electrically balance this as well. So how do we do this? We need to count up all the charges. On the reactant side, we have a positive 8 charge coming from all the hydrogens and a negative 1 charge coming from the permanganate, yielding an overall charge of positive 7 on the reactant side. Now we go to the products and we see a positive 2 charge on the manganese and a charge of 0 on the water because of water's electrochemically neutral. And that leads to an overall charge of positive 2. So how do we get positive 7 to equal positive 2? We need to subtract 5. How do we subtract 5? We add 5 electrons to the reactant side. So now we're all electrically balanced for the permanganate half reaction. Now we need to electrically balance the iron half reaction. So how do we do this? We need to make this positive 3 charge equal this positive 2 charge. This means we need to subtract 1 from this 3. Again, how do we do this? We add 1 electron to the iron. All right, so now this iron is chemically and electrically balanced. However, if we're going to combine these two half reactions in order to form a full balanced chemical reaction, we're going to need to make sure that the electrons equal each other on both sides in order to allow for us to have them cancel out. So what do? We're going to need to multiply the iron half reaction by 5 so that the 5 electrons on the product side cancels out with 5 electrons on the reactant side. However, we're also going to need to multiply the irons by 5. So now we have 5 moles of iron on each side of this half reaction. All right, now we're all set electrically and chemically in terms of balancing. So we can add these equations up. All right, we're going to go ahead and cancel the electrons because they are equal to each other. And then we are going to have a full balanced chemical reaction of 8 hydrogens, 5 iron 2 ions, 1 permanganate, and that's going to then form products of 5 iron 3 ions, manganese 2 plus, and 4 water molecules. All right, so now we can determine the reducing and oxidizing agents. The iron 2 plus, or the iron, is going to be the reducing agent. This is because it is what is getting oxidized. Henceforth, it is going to be able to reduce the permanganate, and the permanganate, or the manganese, is going to be the oxidizing agent because that is what is being reduced. Henceforth, it is causing oxidation in the iron. All right, so now we can go ahead and do an electrical check to see if the charges are balanced. We have the charge of positive 8 on the hydrogens, a charge of positive 10 on the irons, negative 1 on the permanganate. That leads us to 17. And then we have 15 on the iron 3s, 2 on the manganese, and 0 on the waters, leading us to 17. Then we can look and figure out what the anode is. That's going to be the iron because it's losing 5 electrons. And then the cathode would be the manganese because it is gaining 5 electrons. So in sum, we needed to find the half reactions. Then we needed to go ahead and find the oxidation states so that we could figure out what's being oxidized and reduced. We then needed to chemically balance them, then electrically balance them, and then we needed to add up the balanced half reactions to get our full chemical reaction.